Okay, so hello everyone. Yeah, so hello everyone. My name is Abhinav Roy, and we are from Sibling Compile Time. And today we are going to start. As you have seen my last stream, I have started a project called Book Your Mark, and the updates will be shared soon. But today we have with us Sukanna Roy. She'll share her knowledge on object-oriented programming. And okay, from now she'll get over the stream. Hello, Sukanna.
Hello.
Yes, you can
Yeah.
continue.
Okay. Hello, everyone. So here, this side Sukanna Roy. I am working in a multinational company as a software developer. So I am here to share my knowledge and give you a brief introduction of object-oriented programming. So, what is object-oriented programming first? So, let's start with what is object. Objects are the basic entity of the software development. Okay. So it can be anything. It can be a person, place, or thing, and it is the instance of the class. So if we know discuss about what is class, so class is the blueprint of the object. So okay, let me describe it in a better way. Yeah, make a suppose a
Hello, I think we are facing a technical problem. We'll come back.
hello.
Yes, yes, you are audible.
Okay.
Continue.
So continue. Should I start again?
No, no, you were stopped, I think, on classes, I think.
Okay. Okay. Classes. Okay. Okay, so where are we? We are in the class. So what I'm saying that class is the blueprint of the objects. So if we consider like a flower is the class, so the rose, lotus, hibiscus, lily, all of the objects, they are the instance of the class. Okay. So in real life there are many classes, and it's hard to manage all those classes in real software development. So designers come up with the concept of abstraction, encapsulation, polymorphism, and inheritance. I will get deeper into each one of this topic later. So these are the four pillars. We can say these are the four pillars of object-oriented programming. So throughout. You can take up any language, but these four are the pillars of object-oriented programming. So coming to the first point, that is encapsulation. Encapsulation is nothing but the wrapping of the data member and the method together into a single unit. Like if you like capsule. In capsule means all the medicines are encapsulated in that little form. Okay. So similarly, the whatever the objects have, that is the data members and the methods, the behaviors, all are encapsulated, or the wrap are all are wrapped into wrapped in the class, and this process is known as encapsulation. Okay, so it hides the internal details of the object. Means you can know, if you are calling that class, you know that the behavior is being done. It's not you. That's hidden. Okay. So in real life, if you see, this prevents the client from seeing its inside view. At the behavior and like at the behavior of abstraction, and inside that, I will come to the abstraction that later. Mm, So encapsulation is like encapsulating the data members and the behaviors of the object. And okay, so it basically it's hide all the information of one object from the other for security reasons and whatever. Okay, now the second part is abstraction. So abstraction, if you see, abstraction is only show you what is you will see only what is necessary to you, and you will not see and hiding the unnecessary things. Okay, like if you want like take the example of a car. Let's go to the real life example first, so that will be easier for you to understand. So if you take the example of a car, so uh, the car is the object. Okay, so you know that it have the brakes and it have the steering, it have the engine. Okay, you just know the uh, the outer knowledge of it. That it has these things. But how these are working? What are the internal? How is this the engine? How the functioning of engine? How the steering uh, functioning? How the brakes are functioning? All details are hidden from you. So this is the abstraction. Means it only shows you what is necessary to you or what is relatable to you. It hides necessary things. So okay. So it also gives a in the software development. It gives you a means it's just a thought process. Means it's just give you what you need and it hides what you don't need. So this is the second point. Encapsulation, we are done with encapsulation, we are done with the abstraction. Now, if you see what is inheritance, okay, so what you mean to inherit? Inherit means you have some things of your parents, you inherit. Hello, hello, okay, so there is some disturbance. Anyways, where were we? Yeah, so inheritance. Inheritance is like uh, it have been a class. So similarly, inherit like you inherit something from your parents, but you have some characteristics of your own. So it is the same process. So it includes some properties of some other class, and it can have a class can have some properties some of other class, and it has some properties of its own. So this is and you can access all the data members and all the functions from your parent class. Okay, this is the process of inheritance, and the main uh, the main what do you say the main um, I'm calling sort of world. The main uh, mm, idea of bringing such a concept is the reusability. Since you have something for your parent class, you don't have to rewrite the same code for the child class. Okay, you can directly access it because it's already there in the parent class. So inheritance is this thing. Okay, now the what is the fourth pillar is polymorphism. So polymorphism, okay, the break the word first. Like poly, that means many, and morphism, it's mean forms. So if something have many forms, then it is known as polymorphism. Okay. So what exactly polymorphism does in object-oriented programming? Okay, like if you can have a method with the same name, okay, and but it can do a different function altogether. Okay, like so what is a need? You will say what is a need? We can have two different method names. Means what is the need of giving a single? What's the so urgent to give the same method name? Okay, so this is like if you have to add two numbers. Yes. Okay. Then method. Firstly, you have created a method named add, and you are adding two numbers. Now, after some time during the process of development, you see you have to add two float numbers. Okay, then you are giving another method add float. Okay, method name is add float. Now there is two doubles number. You are giving add double. So it's the method names are so complex. Like you get confused. Means what is the method you have used there. So to maintain the consistency of the code, what you can do. There is a concept of overloading and overriding that is polymorphism only, but I'll discuss that in some later part. Just today is I'll give you just overview, and during the process of making you understand, I'll means when I will do the hands-on, I will give you the brief concept of each topic. So while coding, I will show you. So overloading and overriding. Okay. So leave the topic here. So overriding is like you can have the same method name add, and you can use that method name uh, somewhere to add float numbers, somewhere to add the integers numbers, somewhere to add the decimals. It's all, but the method name will be the same, but the functionality will be the different. So this way, the consistency of the code will be maintained. It is easy to maintain the code. So these are the four pillars. Okay. Now, if I give you okay, so these are the four pillars. And now, if you, I'll go through the okay. In the next topic, if I show you in the next day, I'll give you a brief, give you an okay. Okay. Let's yeah. We'll take up each topic again. Okay, with some deeper knowledge. Like I'll give you the differences between okay, like abstraction and encapsulation are two very confusing terms because sometimes they confuse like encapsulation is also hiding it and abstraction is also hiding the hiding. So what is the difference between these two? But the thing is like abstraction if so I'll give you a brief difference of this in the next lecture. But today, just like you can understand, like abstraction is like giving you just the overview, giving you solves the problem at the design level. But encapsulation solves the problem at the implementation level. Means how it is implemented, it is being hidden. It is being hidden. Okay, but in abstraction, it's just showing you these are the things you need and these are the things you don't need. So we are not showing you this. We are showing you this. These are the things. Okay. So we'll go through the examples. We have given you the real life examples today. In the next lecture, we are more into the coding part and more into the technical terms of these four pillars. And so and you can comment if you have any questions on these four pillars. I'll cover it up in the next lecture, and I'll share means how the real the coding structure of these four. Okay, so go through your own. Okay, then. Okay, bye.
Okay, thank you, Sukanna. So here we end our stream. Uh, my updates on the projects, I'll bring that on, I think, tomorrow or day after tomorrow, because my exams are going on. I cannot keep up with the pace of the project. And yeah, if you like this content, please share.